open any website and it shows you maybe 10 pages. But behind those, there are often hundreds more that it never links to: old admin panels, backup files, config files, hidden API endpoints. The site doesn't want you to find them, but they're sitting right there, one guess away. This episode is Content Discovery, the art of finding all the hidden pages, directories, and files a web server is quietly hosting. This is where Recon stops being a list of hosts and starts becoming real, exploitable attack surface. Let's go find what's hidden. Bridge. Last episode, you resolved your subdomains and probed them, so now you have a clean list of live web servers. Content discovery is what you do to each one. A live host is a door. Content discovery is walking every hallway behind that door, opening every room, and finding the ones that were supposed to stay locked. You're about to turn each website from a handful of visible pages into a full map of everything it can do. So what exactly is content discovery? A website is really a collection of files and folders on a server. It links to the ones it wants you to see: the home page, the about page, the login. But there are almost always more that aren't linked anywhere: forgotten uploads, developer tools, backups, admin interfaces, API routes. Content discovery, also called directory brute forcing, is the process of guessing those hidden paths, requesting each one, and seeing which actually exist. You're not hacking yet, you're finding the doors. The mechanic is beautifully simple. You take a word list, a big text file of common file and folder names, admin, backup, login, config, uploads, and thousands more. Then a tool requests each one against the target, for example, target.com/admin, target.com/backup, and so on. For every request, the server answers with a status code, and that code tells you whether the path exists. Do that 10,000 times per minute, and you rapidly map what's really on the server. Reading those status codes is the core skill, so let's be clear. A 200 means the page exists and loads, an obvious hit. A 401 or 403 is even more interesting. It means the path exists, but you're not allowed in. That's a locked door worth attacking. A 301 or 302 is a redirect, often pointing you somewhere useful. And a 404 means not found. The path isn't there. Ignore it. The beginner mistake is only caring about 200s. The pros get excited about 403s because forbidden means there's something they're worth protecting. Now the tools, starting with the fast one, ffuf. ffuf is a blazing fast web fuzzer, and it's the industry favorite. You give it a URL with the word FUZZ as a placeholder and a word list, and it swaps FUZZ for every word in the list, firing thousands of requests a second. So ffuf-u target.com/fuzz-w your word list. In seconds, you get a live list of every path that responded with its status code and size. It is the workhorse of content discovery, but raw ffuf output is noisy, and filtering it is the real skill that separates beginners from pros. Some servers answer 200 to everything, even garbage paths. So you filter by response, filter out a status code with -fc, or a specific response size with -fs, or a word count with -fsw. The trick: run it once, see what the junk responses look like, then filter those out so only real interesting results remain. ffuf can even auto-calibrate this for you. Master filtering, and a wall of noise becomes a short list of gold. Here's a multiplier most beginners miss: recursion. You find a folder called /admin. Great, but /admin probably has its own hidden files and subfolders inside it. So you should brute force inside every directory you discover, and inside those, and so on. Doing that by hand is painful, which is why feroxbuster exists. Feroxbuster automatically recurses. When it finds a directory, it dives in and keeps fuzzing, mapping deep folder trees on its own. Set it running, and it explores the whole structure while you watch. A third popular tool is dirsearch. Where ffuf is a raw fast fuzzer you configure yourself, dirsearch comes batteries included, sensible defaults, built-in word lists, and it automatically tries common file extensions for you. For a lot of hunters, dirsearch is the quick first pass, point it at a host and go, and ffuf is the precise, heavily filtered follow-up. Different tools, same goal: uncover what's hidden. Speaking of extensions, this is where real treasure hides. Don't just guess folder names, guess file endings too. A developer edits config.php and leaves a backup called config.php.bake, which the server will hand you as plain text source code and all. People leave .zip and .tar archives of the whole site, .git folders exposing the source history, .env files full of passwords and keys. So always fuzz with extensions, .back, .old, .zip, .json, .config. The file endings are where secrets leak. Your results are only as good as your word list, and the gold standard is a collection called SecLists. SecLists is a giant organized library of word lists for exactly this. There are lists of common web paths, of API endpoints, of backup file names, and lists tuned for specific technologies. The famous ones for content discovery are the raft lists and directory list files, built from millions of real websites. Small, smart, curated lists beat huge random ones every time. Install SecLists once, and you use it in every single engagement. But the very best word list is one built from the target itself. Every site tells you its own secret vocabulary if you listen. Pull all the URLs a site has ever exposed with a tool like GAU and scrape the JavaScript files the app loads because they are packed with API paths and endpoint names. Feed those words back in as a custom word list and you'll discover paths no generic list would ever contain. Generic lists find the common stuff. Target specific lists find the unique stuff nobody else does. Modern apps are mostly APIs, so content discovery has to go beyond web pages. Behind the scenes, the site talks to endpoints like /API i/v1/users. You find these by fuzzing API-specific word lists and by reading the JavaScript, which literally lists the endpoints it calls. Even better, many APIs expose a documentation file, a Swagger or OpenAPI spec that hands you every endpoint and parameter at once. Find that file and you found the entire API documented for you. There's a hidden layer even deeper than paths, parameters. A page like /search might quietly accept a debug parameter or an admin parameter that changes how it behaves, and hidden parameters are where tons of bugs live. You discover them by fuzzing parameter names, and the go-to tool is Arjun. Arjun throws thousands of common parameter names at a page and watches which ones actually change the response. Finding an undocumented parameter is often the first step to a real vulnerability, so once you found the pages, fuzz their parameters too. A serious word of caution here, because content discovery is loud. You are firing thousands, sometimes millions, of requests at a target. Go too fast, and you can slow the site down or knock it over, which is damage and it's out of scope. So throttle your speed, respect any rate limits, and never point this firepower at something you're not authorized to test. Fast is good. Reckless gets you banned or worse. Stay in scope and stay considerate. Once the tools finish, you'll have a list of discovered paths, and now you triage, deciding what's actually worth your attention. Some hits are boring. Others make your heart race. Anything called admin, dashboard, or console. Anything with backup, old, or dev in the name. Expose.git or .env files. Config and database files. Upload and file manager pages. Documentation and API specs. You scan the list for these high-value words, and those become your first real testing targets. The map is done, now you pick where to attack. Let's tie it together into one flow. Take your list of live hosts from last episode. Run a fast first pass with dirsearch or ffuf and a solid SecList word list. Recurse into everything interesting with feroxbuster. Layer in extensions and target specific words from the site's own JavaScript. Filter the noise, then triage the survivors for the juicy names. What comes out is a rich map of hidden pages, files, and endpoints, your real testable attack surface on every host. The mistakes that leave findings on the table: 1. Using a single tiny word list, you miss almost everything. Use SecLists and target specific words. 2. Not filtering and drowning in false. 200s, learn your filters. 3. Ignoring 401 and 403 responses. Those forbidden doors are often the whole point. 4. Forgetting file extensions and missing the backups and .git leaks. And 5. Going too fast and harming the target. Discover thoroughly, filter smartly, and stay in scope. Why does content discovery matter so much? Because the vulnerabilities almost never live on the pages a company shows you. Those got tested. They live on the forgotten ones, the staging login nobody remembers, the backup file with the database inside, the admin panel with no authentication, the debug endpoint that leaks everything. Content discovery is how you find those. The visible site is where everyone looks. The hidden site is where the bugs actually are. For a recap, content discovery finds the hidden pages, files, and endpoints a server doesn't link to. It works by fuzzing a word list and reading status codes. And remember, 403 and 401 mean something's there. Use ffuf for speed, feroxbuster for recursion, dirsearch for a quick pass. Feed them SecLists plus words from the target's own JavaScript. Always add file extensions and fuzz parameters with Arjun. Filter the noise, triage the gold, and stay in scope. In short, you can now map every hidden corner of a live website. But some of the juiciest intel isn't on the target at all. It's scattered across the public internet in search engines, code repos, and archives. Next episode, Google docking and OSINT using advanced search operators, GitHub docs, and the Wayback Machine to find leaked secrets and forgotten pages without sending the target a single request. Subscribe so you catch it. And tell me, what's the best hidden file you've ever found? See you in the next one.